Okay, so today what we're going to be looking at is we are going to be looking at the mean and the standard deviation and how data is, because the standard deviation is how data spreads around the mean. So the first thing is that we're going to use this 68, 95, 99.7 rule. So it's a rule that we say that you can use every time, but only if the data is approximately symmetric. So what you're going to say is you're going to see that bell shape. So when we see the histogram and it's that bell shape like that, okay? So they will always tell you in the questions, you will see this wording that the data is approximately symmetric, or sometimes they'll say it's a normal distributed, or sometimes I'm going to write above it, they sometimes say it's normally distributed. Okay, just so you know, if you see those words, we're going to be using the mean and the standard deviation. So remember that. So here I've got a little picture down here. I've got a picture of a bell-shaped data. Say our data looked like this. Okay, when you have symmetric data like this is, the mean will be the value in the middle. Okay, so I've used the symbol for the mean. So remember on our calculator, they use that X with a line above it to symbolize the mean. And what we're going to do, we worked out that standard deviation. So I want you to write that. Remember, SX was standard deviation. So what this rule tells us, if we add to the mean value, if we add, say, we're going to add 1 standard deviation, or we could add 2, or we could add 3. And we also can go minus 1 standard deviation, minus 2, and minus 3. So remember that standard deviation is going to be an actual number, and so is the mean. So the first thing we know about symmetric data is that 50% of the data is going to be above the mean and 50%. So say, for example, if I surveyed 100 people's, and, say I surveyed, their height, and it came out symmetric, we're going to say 50% of the people are going to be above the mean. So there'd be 50 people above that mean height, and there'd be 50 people below if it's showing a symmetry. So what we go to the next thing is this 68, 95 or 99.7 rule. So let's look at the first one is 68. So what we're going to have is we're going to have the mean, an actual value, and then when we add the mean plus 1 standard deviation, so we'll just put SX there because we call it SX, or the mean minus 1 standard deviation. So when we do that, we end up with this actual value. And if we go plus or minus 1 standard deviation, so when we say plus or minus 1 standard deviation, 68% of the data is going to lie in there. So if I surveyed 100 people, 68 people are going to be between those two values. Okay? And then you can notice, if we know there's 68% in the middle, then those two tails, because it's symmetric, and it's a mirror image, that's why these two tails end up being 16% each. So we can use this to interpret some of the data. So say I was sitting at say we were talking about heights, my height might have been the mean minus 1 standard deviation. So that means I'm only taller than 16% of the rest of the people surveyed, okay? So this is what we're going to use. So this rule is 100% for all symmetric data. This is what we say. So that's when we have 68. When we have 2 standard deviations, so it means we took the mean and we added 2 times the standard deviations. So or the mean minus 2 times the standard deviation. When we do that, well, 95% of the data lies between those two values. Okay? And then the last one is when we go 3. So we'd have the mean and we'd have plus 3 times 3 standard deviations, or the mean minus 3 times the standard deviations. So when we get there, we're going to get 99.7%. So when we've done 3, we've nearly got the whole data source. So we often say that's a majority, but it's not quite. You do have these tiny little tails. So we're in that. So what happens, this is your VCE scores. So they make it normally distributed. So they make you fall into this bell shape so that they will only have a certain percentage in the top and a certain, so see if you look at the 95% of your scores are going to lie between 1 or 2 standard deviations. So that was just explaining the rule. Let's see the rules in action so you can understand what you're going to get asked about. So here in the question, it says the distribution of examination scores for a very large statewide exam is approximately symmetric. So can you see that approximately symmetric? As soon as you see that, that should be triggering that you are going to use the mean and standard deviation, okay? So you pretty much know when they say that, you're probably going to be using this 68, 95, 99.7 rule. Okay, so they've said it's symmetric and bell shape, same thing, with a mean. So then they tell us in the actual question what the mean actually is. So underneath that, I'll draw the mean, because I know that's a mean, and then it said this and a standard deviation of 10. So that is my standard deviation there. Okay, so when they ask me, they go, so this exam, say it was a percentage, the mean score was 65%, okay? And then they say approximately what percentage of students scored between a 55 and 75. When they give you these numbers, they are going to link in with your standard deviation. So what I'm going to show you, and these ones are always better if you just quickly draw a little bell shape for yourself. So we're going to draw a little bell shape. Now, they told me that the mean was 65. Okay, so I'm going to put that in there. Then, if I add 1 standard deviation, what's 65 plus 10?
75.
Yeah, so 75 would be at 1 standard deviation. If I add another standard deviation to that, what am I going to be at? 85. And then I add one more, what am I going to be at? 95. Then I'm going to subtract it. So what's 65 minus 10? 1 standard deviation would be 55. And then we're going to minus, if we minus 2, we're at 45. And we minus 3, we're at 35. Okay, so this is what we see. So what I'm going to do is I'm going to show you in the colours. So the first one, they asked me, this A, they asked me what percentage lies between 55 and 75. So if I go over to my little diagram, 55 and 75, that was plus 1 or 2, plus 1 or minus 1 standard deviation. So in our rule, what was the percentage when we were plus or minus 1 standard deviation? It was 68%. Do you remember that? So going back, so because 55 and 75 is plus or minus 1 standard deviation, I know because of the rule, I can say 68% of the student scores lie between that. All right, so for A, we'll say 68% of the student scores lie between that. Lie between, that's my abbreviation for between 55 and 75. All right. So then if I'm going to do B, this one, I'll do it in green. It says, what percentage of the students lie between 45 and 85? If I go to 45 and 85, that's plus or minus 2, isn't it? Standard deviations. What was the percentage in between plus or minus 2 standard deviations? It was 95, wasn't it? So when we look back at our diagram, when we were 2, that was 95%. So we're going to say 95% between 45 and 85. And then the last one, I'll just do it in black. So this black, when we are between 35 and 95, if you look up here, that's 3 and 3. If we were plus or minus 3 standard deviations, what were we? 99.7% between 35 and 95. Okay? So if I got 80, say for example, if I got 85% on my test, on my exam, I'm going to say I'm in the top 16%. Why do I say that? Because, I shouldn't say that. I'm in the top 2.5%. Because when you have 2 standard deviations, this little pocket is 2.5%. So because I got an 85, I can say I'm in the top 2.5%. Okay? Okay, so the distribution of delivery times for pizzas made by House Pizza is approximately normal. So approximately normal is another way of saying symmetric data. Okay, so symmetric data. Okay, the word normal means symmetric in our stats. Okay, and then it says we have a mean of 25 and a standard deviation of 5. So they're going to ask me all these questions as soon as I see that. So I'm going to quickly draw my diagram because it'll just make my life so much easier, and then I'll be able to quickly answer the questions. So we said mean was 25, and because they said standard deviation, so you're either going to go up 1, 2 or 3 standard deviations, or you're going to go down 1, 2 or 3, and you just pop the numbers in, because if the standard deviation is 5, what's 25 plus 5 would be 30, plus another 5, 35, plus another 5, 40, and then I can minus 5, so I'd be 20, 15 and 10. So then when they ask me my first question, they just say, what percentage have a delivery time between 15 and 35? So here I'm at 15 and 35, so that's plus or minus 2 standard deviations, and according to our rule, 95. What's that? 95%. Good. So you can just write 95%. Okay, for B, it's saying between what percentage of pizzas have a greater than 30? So you go to 30, right? And 30 is sitting here at 1 standard deviation. So go look at your diagrams. When you have 1 standard deviation, what percentage was the pocket? It was 16%. So how much was bigger than 30? In that case, you would say 16%. They're asking you what the pocket is, yeah? What was greater than that? So you can use your, those diagrams. Go back and reference it and check it. Okay, for C, in 1 month, the House of Pizzas delivers 2,000 pizzas. So here you got told an N. Remember, all right, they did 2,000. And approximately how many pizzas of these pizzas are delivered in less than 10 minutes? So if you go look at where 10 minutes is, so I've gone down, here's 10. And 10 is at -3. So they're saying less than 10 minutes. So what was that little pocket when we had -3? It was a tiny little percentage. Yeah, it was 1.5. So what we're going to do is we're saying 0.15% of the 2,000 delivered were less than that. So be careful, this is how we're going to change this to numbers. So when we write a percentage, you can put it just over 100, okay? Because this is even less than 1. This is a tiny bit of percent. It's not even 1%, it's even smaller. So maybe just do this. The word of means times, and then we do 2,000 on our thing. So let's work that out. We end up with 3. So approximately 3 pizzas were delivered in less than 10 minutes out of those 2,000 pizzas, okay? Okay, the distribution of diameter of bolts produced by a factory is approximately symmetric and bell-shaped. So there it gives it away to the question that I must be using the mean and the standard deviation, and I'm going to be using that 68, 95, 99.7 rule, okay? It's a giveaway, and it's a giveaway next year as well, okay? So with a mean, so I write that of 5 and a standard deviation of 0.01 millimeters. So they're going to ask me a whole heap of questions on it. So I just like to, all right, I'm going to put a visual, because some of us can't retain that information. I can't. I'm not very good at retaining the words. So I like to just draw a diagram of what they told me, and then I'll answer the questions, and when I come back to check, it's easy for me to check because I can see what I've done. Okay, so 1 standard deviation would be 5.01, 2 standard deviations would be 5.02, and 3 would be 5.03, and then I've got a minus, so it'd be 4.99 and 4.98 and 4.97. I was just minusing 0.01, the standard deviations. So it says in this question A, approximately 68% of the bolts measure between A and B. What are the values of A and B? So we know 68% is plus or minus 1 standard deviation. So we've got to go to that. So there's 1. So what's it going to be lie between? A would be the lower one, wouldn't it? Which is? What's the lower amount? 4.99. Yeah? And that's A. And B would equal the 5.01. Okay, so what are possible values for A and B? There we go. Now, if we look at B, if it says 95% of the bolts lie between C and D, how many standard deviations is the 95 one? 2. So we'll go up here. Here's 2 and 2. So it's going to lie, C is going to equal the lower one, 4.98, and D will be the higher one, 5.02. And then the last one, C, it says approximately 99.7 lie between E and F. What are possible values? What could E be? So what's 99.7 is 3. So it's going to be E could be 4.97 and F is the higher one, 5.03. Okay?